This talk is about IPFS, which is Interplanetary File Storage. Woo! This is like, what? Like, just by the name, I'm like, are you going to be sending stuff to Mars using... So I'm like hyped. You hyped? This, like, shit. IPFS, everybody. So this is going to be a primer, IPFS and some crypto and some Web3. I'm excited because you know what? Anyone else feel like FOMO about Web3 and you're just like, I see hype, but I don't know if I should. No one. Come on. And now you're like giving me pity hands. Yeah, but I see. Yeah, that's the one. They're all Web3 experts. Yeah. I see Tom's over there, like me. So I personally, I see a lot of hype. I don't get most of it. I'm a bit ignorant here, so I'm really excited for this talk. Everybody, will you give the warmest welcome to Konstantin?
I can do it. One, two. Amazing. Three. 1, 2, 3. Make no problem. Simple. Yeah. 1, 2, 3. Perfect. Then I'm speaking with you like that. And thanks for an amazing introduction about space. We are literally just our first node to be in space last month. So it's actually literally interplanetary, but I will get to that really in a second. So first of all, I'll go you through the introduction to IPFS and Filecoin and how they shape the future of Web3. The reason I'm presenting it in this way is because there is a lot of stuff is happening in Web3 right now. But in the same time, developing stuff in Web3, you just get overwhelming amount of content, overwhelming amount of information, but you are still kind of losing the track of what's happening every day to day, what are the projects appearing, what are the projects disappearing. So what I rather would like to focus on is what matters for Web3, and what matters not only for Web3, but what matters for everyone else, for everyone here to know about it or to think about that can change the way you work, that can change the way you think about something, or that can help you working or help you today life. So first of all, I would like to introduce you to a company a little bit. Give me a hand, raise me a hand, someone who have heard about Protocol Labs or IPFS or about Filecoin. Okay, that's a good starting point. So who of you heard about Web3 in general then? And who of you ever touched the topic of storing something on Web3? How the storage in the Web3 works, how they approach it? Oh, that's amazing. You're an amazing audience then, and I would just give you a brief. Are we doing what the Protocol Labs is? Yeah, sure. In 2 minutes as well? Yeah. Well, but 1, 2, 3. Oh yeah, that's better as well. And do you still hear me like that? Amazing. So first of all, Protocol Labs by itself is decentralized organization, if you can say so. So Protocol Labs is an open source R&D lab which is building protocols, tools, and services to improve internet. And the same fashion the Web3 is trying to be distributed or going to be distributed, we also have multiple organizations inside of us which are building different tools and different solutions. So under us, we have Filecoin Foundation, which is a steward for Filecoin community or which aspires to put the power in humanity's most important information and back it up and give it hand to everyone. And we develop multiple protocols, including IPFS, which is a peer-to-peer protocol that making the web upgradable, resilient, and more open. And we develop Filecoin, a decentralized storage network to store most humanity important information. And regardless of how many organizations, how many protocols or tools we build, I think it very resembles with the previous talk about that we are, first of all, a community of people. And we are building a better future together, regardless how we structured or how we organize. We are actually aiming to do something good for everyone, not only just for the sake of a company. Thank you. And in order to do so, we are developing multiple tools. And first of all, I will go you through the concept of IPFS and Filecoin. So You know all this history. You know probably even better than me, but essentially we were transitioning from the internet, where we have wires and networks, to the Web 1, which was read-only. It was static websites. You cannot interact with them. You just upload content and it's there. Then we transitioned to Web 2, which was read and write. It enables us to be an interactive in the internet, and that's what the most of the tools you're using day to day is about. It's about Web 2. You can read, you can write. But is that it? So I would say that the Web3, or the essential part of Web3, is enabling trust in this read-write-trust sequence. It's a next evolution of web where trust has been an operative thing, and it allows you, or it is achieved through verifiability and a whole bunch of underlying primitives that builds up on top of the technology that allows you to enable web which is verifiable and trustful. What does that mean? I mean, we are all transferring from somewhat centralized solutions of the Web 2 to a more decentralized and hopefully to the distributed space. So centralized, and why everyone bash it, I mean, you all face the centralized solutions day to day. Google, Cloud, Facebook, Instagram, all of those are, first of all, single points of failure. Moreover, you are really locked into one particular solution, so you cannot really switch from this solution to this solution. The migrating is very hard. Changing a provider is very hard. And essentially, especially in the social apps, you are essentially locked in an app because all your friends are there. You cannot really move data from one place to another. And the data, in the end, which you put into the app, which you believe is your personal, is still monetized by the data monoliths, which store it and makes the best use of it. So instead of having these central points of failure and data silos, we are believing that the web should be decentralized, and moreover, it should be distributed, where the users power the service, not the other way around. Not the service powers the users, but rather users have the control of their own data. They can freely move it so that there is no censorship resistance. There is privacy inbuilt by design, not by what a certain tool offers you, because, well, in the WhatsApp, okay, now they enabled end-to-end encryption, but it was a long time not in place, and you couldn't choose that because you were still all the friends and families there, and they still somehow utilize your data. And it should be also self-verified and non-siloed, so that you're not locked into a particular tool. You can self-verify if the content you're working with is what you're expecting to work with, and it should not be handled by someone else, but by you or by the protocol by design. And going to the decentralized space, the beauty of it is that there is no one central solution or one central stack which does everything. Instead of that, we built multiple building blocks, and whoever builds their own solution or a project can utilize different blocks, and he's not locked into any particular project or a solution. Instead of that, you can utilize different blockchain layers, you can utilize different side chains, you can use different environments, you can use file storage, you can use indexing, querying, et cetera, et cetera, et cetera. And for whatever project you are building, you can combine these different pieces together, find them in the most suitable spot or architecture you enjoy, and then just build your protocol or project on top of that. We also contribute as IPFS and Filecoin to the file storage layer, but we are not only file storage, we are also providing off-chain data protocols. We have our own blockchain one layer, and we enable people to have the pipeline of a data storage in the Web3. And we believe that in Web3 stack, verifiable data is essential to a truly distributed system. And in the next 30 minutes, I will walk you through concepts of IPFS and Filecoin, what is peer-to-peer hypermedia protocols, and I will tell you that files and folders are not boring, and they're actually super exciting to work with. So first of all, let's go to the IPFS. IPFS, thanks for the introduction, it stands for Interplanetary File System. So let's break that down. So first of all, file system is the usual files and folders. And Interplanetary, we understand it as distributed. So there is no central server, and it's resilient and online first. And why it matters to be like that in an interplanetary scale system? Because imagine we colonize Mars at some point. And if we continue to use the same tools as we have right now, including Google, Facebook, any call which you want to do from Mars will take an hour to get to Earth and backwards. And going back to Earth every time you need something on Mars is just very awkward and stupid. But imagine instead of having to talk with a centralized solution every time you want to do something. You just have a distributed network, which if anyone has copied the data you wanted on Mars already, you can just request it from him directly. And that's exactly what IPFS does. It builds a network of communication nodes, which allows you to retrieve the content not by a central authority, but by whoever owns or has the same copy of it and can retrieve it to you whenever you need it. And it's, again, distributed, so there is no central server. Instead of asking, hey, where is the data located which I wanted? Instead of going to a certain IP or port, you just ask the whole network, who has this data? And if network has it, the closest node to you will deliver it to you in the same way maybe as torrents work. And to give a better perspective of that, IPFS essentially addresses the content by what it is instead of where it is. So you're all familiar with computers and how the files and folders work there. So in order to find a certain file on your local machine, you go to a file, to a path, to index, you found it. The same works in Web 2. Essentially, when you want to download an image of a cat or a meme, you go to a domain, you go to a path, to there is your image. Instead of that, we replace a folder or a file with a content ID. So we create for any content you upload to the network a unique identifier, which is called CID or content ID, and it provides you pointer to the exact content which you have, whatever it is. And to give you a better example of how it works, imagine a friend tells you, hey, you should read this great book. And instead of telling you which book you should read, he tells you, you can find it in New York Public Library. You go to section 9, to the bookcase 3, top shelf, first from the left. That's already awkward. Okay, but you trust your friend, you think that the book he recommended is great, so you go to the New York Public Library, to the section 9, to the bookcase 3, top shelf, first from the left. And the problem is it's the same book as you had in a backpack. And that's super awkward. And that's exactly what our internet is doing to us right now. Instead of telling you, oh, this is a content, it tells you where to go for it, and you don't even know what content is inside until you reach it. And instead of doing so, there is a way, way smarter way to do it by creating, first of all, you can use any content in IPFS network, and you create a cryptographic hash function, or SHA-256, and you create a content identifier for it. It's a unique code which belongs to the same content, and it only points to the exact content it is. If any bit inside the content changes, the cryptographic hash function would be completely different, and it's a one-way function, so you never know what you are working with until you actually downloaded it. The beauty of this structure is that whenever you work with the same content, it is the same CID. What does that mean? Whichever computer you use to create this function will always generate the same code for the same object, whether it's an image, whether it's a video, regardless, whether it's a file folder. So the same content is same CID, and content ID can be reproduced anytime from the original content. Also, the beauty of such design, so whenever you request a content by a CID, you can always verify what you have received by creating a CID again of the object. And if it matches what you originally requested, then you are working with the right content. If you are receiving a different CID from what you requested, then there is a flaw, there is a malware, something is problematic in the network. And you can not only work with the content as like files and objects, you can also work with the folders. So folders are essentially kind of file which just lists other files in it, and the core principles for IPFS remains all the same for any structure or any data you use with it. When it comes to folders and structures, you can literally operate within IPFS with the folders and structures with the pointers and the CIDs. So on the bottom, we have 4 different images, and they are grouped in 2 different folders, and they are grouped into one big folder which has a root ID. And every picture and every folder inside the system has a unique fingerprint, which is exactly the CID I was talking about just before. And we have Merkle DAGs, direct acrylic graphs, which are data structures in which each node is content address. So whenever you point into anything in our IPFS network, you actually have the CID of the content. And you can point not only to the object, you can also point to the folders and find the content whenever you need, however you need. The beauty of such system is when you create a folder structure, which with the content which already on IPFS, you just point to the same CIDs because same same CID. And you essentially can deduplicate the whole internet because the copies of the same files are the same things. So you create a new folder, you have the references to images, but these images already live on IPFS, so you just do not need even to upload them. You just have the references to them, and they're available on the network already. And this also brings you the verifiability. So if the content changes, the CID changes. At any point of time, you can check whether you are still working with the same content you're expecting to work or not. And that's deduplicating the whole internet, essentially. You don't need to store the same images over and over again, providing it in many, many countries and places. You just rather store it the minimal required amount to do it redundantly, so the content persists on the web, but then you can just retrieve it from the closest node instead of really going to a server and downloading the content from there. In order to this system to exist, you need to have a complicated system of content, of peers, of swarm, and it's also all handled by this open source protocol. So first of all, in order to work with an IPFS network, we have a swarm of peers. So everyone participating in this network is essentially a node and has same properties as everyone else. But they should all be, first of all, discoverable, and they should be routable or reachable. So whoever participates in a network and provides content on IPFS has to be discovered, to be pointed to, and need to be reachable through the network so that at any point of time you can discover all what's happening in the network and receive the content which you're looking for. For that purpose, we have distributed hash tables, and I believe me, that's the last 2 slides of deep technical information, so you're not too down or not focusing anymore. But this distributed hash tables is essentially what enables us to organize the whole network, not by maintaining the one list for everything, but rather creating distributed hash tables for a small group of peers, which are maintaining it as a phone book altogether. Imagine, and I can give you an example of maintaining it all together. Imagine you and your group of friends sharing the same phone book. So you have a name of a person and a phone number, and you are maintaining it together all across your group of peers and stuff. The reason to do so is because you don't need to add duplicated information. Whenever someone meets from your peer or friends a new friend, he adds it to the common shared book, and then everyone had the access to it. And it's exactly how distributed hash table works. It provides you the key and the value to point it to. And peers, every peer in this smaller group can, first of all, query the DHT, so they can discover the peer ID, which provides specific CID, and you can understand and trace what's happening in the whole network. And these smaller DHT tables are maintained by a group of peers. So if someone is requesting information from a peer and it doesn't have it, it asks the nearest DHT table, hey, do you have it? If they also do not have it, they point it to the probable, most likely other DHT table, and that's how peer discovery or content discovery happens in the IPFS network. And distribution of the CIDs across the network is happening in a logical way, so that you don't need always to query through the whole DHT tables of all the peers existing in the network. You rather is able to point where are the most likely location of the next CID to appear, and just go with a higher probability to ask these DHTs instead of the whole network. So let's summarize that a bit. First of all, you have one CID to rule them all. You have a CID for content, folder, IPNS, nodes, network. Everything could be described by a CID, and everything could be understood by a CID. So whenever you ask, hey, give me this CID from IPFS network, it will point you either to the content, to the folder, to a pointer to another content, or to the node itself as like who runs it and who owns it. And then you do not need to know where it's stored. So whenever you have a CID you want to retrieve from a network, you don't need to go to someone and tell me, you should have this content, please give it to me as a server. No, you just ask the whole network, hey, network, do you have this content identifier? And if it has it, it will retrieve it to you regardless if it's coming from a peer, from a DHT, from IPFS nodes, from Filecoin, from AVS, from many, many more. Whenever you use CID as a reference, you can request it through the whole network, and people can retrieve it to you back whenever you need it. So that's like how all the architecture works. And let me tell you about how it works in the wild. So all of that before was like a theoretical concept of how peer-to-peer networks work. In order for you to actually utilize the system, So first of all, obviously, you can run your own node. Then you can retrieve your content from there, but if your node is too far or goes offline, there is no reliability or redundancy. So then you can also run a network of nodes, but then you are also facing the problem of infrastructure team and managing of the servers or multiple nodes at the same time, which is also not very convenient. You can also pay a pinning service. There are existing solutions like Pinata, Temporal, and Fura, which can pin the data to IPFS nodes for you in our network already. And in the end, you can hope that your content becomes popular enough and enough people copies it so it becomes reliably accessible over time in the network. But does that all sound to you as truly decentralized and reliable solution where you have to trust someone to actually store your data? Not to me. And that's exactly where Filecoin comes into place. So Filecoin is a storage designed for Web3 from the grown up. Filecoin is based on top of IPFS, so it utilizes the same CAD pointers and content addressing in the web, and it's compatible with IPFS and Web3. It provides you a verifiable storage via cryptographic proofs, so you can verifiably check whether your content on the network is stored, how many copies is stored, and in the blockchain, people have to submit proofs that they store your content every 24 hours, so it's verifiably available to you whenever you need it. And the beauty of it is that it's also self-managed by an open market of storage deals. So instead of having one centralized solution or one authority holding all the storage capacity in the network, we have more than 4,000 storage providers which committed some parts of their storage facilities to their Filecoin network, and they store the data on your behalf. And at the moment, this self-managed open market is already accounting for around 18 exabytes of total data capacity, which everyone can use and participate to store their own content, their company content, whatever project they're building on top. It could be reliably and redundantly stored with IPFS. And let me tell you about how specifically the Filecoin works and enables all these features. So Filecoin is essentially incentivizes persistent and verifiable storage designed for Web3. Whenever you have a file and you put it to the IPFS network, you have the CAD. The CAD then could be placed into the Filecoin network, and you can make a deal, which essentially is agreement between you and a storage provider that he stores your content for a certain time period. Right now, the Filecoin deal is maximum to 18 months. So the storage provider guarantees that every 24 hours across these 18 months, your content will be available through the Filecoin network. If you want to store it for more, you can just renew the deal after it ends, and then storage provider will continuously store or perpetually store your content and make it available for you for the lifetime needed for this particular storage. Moreover, you can also achieve redundancy, and whenever you place an object to a Filecoin network, it's stored at least 5 times redundantly, so that even if something happens with one storage provider, the content is still persist on the chain, and whenever you see that there is less copies of the content that you desirably want, maybe a 5 or a 6 would be an optimal amount for redundancy, then you can just make another deal and essentially automatically renew for the duration of the content which you needed. And then, again, Filecoin is also agnostic from where the content is coming from. You can also have cloud and CIDs in the cloud, and then you can also renew the deal directly from the cloud to Filecoin, or you can use other permanent solutions which are relying on probabilistic and unverifiable assumptions. But in a sense, Filecoin enables you to retrieve your content at any point of time, but the content is managed on your behalf by a pool of storage providers across the Filecoin network. And to sum it up, IPFS truly loves Filecoin. IPFS is there for fast and flexible retrieval. It provides you the gateways, the local nodes, the browsers. And Filecoin is there for persistence, which ensures that your content lives in the web and is persistently and verifiably available to you whenever you need it. And to compare it maybe to traditional cloud networks, first of all, we provide the decentralized solution where the addressing on the accessing the content on the web is content-based or CAD fingerprints. It's natively immutable, but we have solutions to add mutability as well whenever you need it. Availability is global, so the whole network of Filecoin is essentially 4,000 storage providers distributed across the whole network, and there is no central provider or central authority who has a large capacity of the data from the Filecoin network. Moreover, the durability is unlimited. You can renew the deal as many times as possible. Therefore, your content persists on the web. And you can easily transfer between one storage provider and another storage provider. There is no locks inside. You'll still operate with the CADs. You just make a new deal with a different storage provider, so you are not vendor locked to a particular solution. And the quality of the service is incentive driven. So all this Filecoin network is essentially incentivizing storage providers to store your data. So in order to this to exist, we incentivize storage providers with a blockchain reward. And whenever they can prove that they store your data, they get a block reward which pays them all the costs which they are running for. Therefore, the cost of storing content with Filecoin the same way you would do it with a regular cloud is at least 100 times cheaper. And that's even an approximation. The actual number is way, way lower. I think we're around 500 times cheaper. But that's like given on a particular case and evaluation how you made it. And that's actually all fully public and online. So all this runs open source. You can validate it by yourself on the chain. And that's the beauty of how you're working in open source in the end, right? So now I will go you through the tools for Web3, or essentially what is available for you right now in order to build with IPFS and Filecoin to improve your protocols and truly live to the open source vision with your content as well. So you can do the Web3 all the way down your project. You can easily enable DWeb. Browser asks for CADs instead of URLs, or your regular browser can ask for CAD via HTTP gateways, which we also built. Then you can load your front end from IPFS. Then you can log in with a DWeb wallet, and then you use Storage Helper. So essentially, all your app is available online, could be done in a Web3 way, and also the things could be done through IPFS and Filecoin in order to host the website, store the content of the website, verify the retrieval, and we are also integrated in multiple browsers or have HTTP gateways, so you can interact with the IPFS network directly from your browser. If you're using Brave, and I would recommend using Brave, by the way, it also has an native support to IPFS inside their browser, so they have the node running whenever you open Brave, so it can resolve IPFS CADs directly in the browser straight away. And whenever you want to build some of this infrastructure for your particular project, there are multiple fancy cool tools which are available for you whenever you want to build with it. So first of all, I can recommend this web3.storage, which is essentially a general IPFS and Filecoin storage. It's a very easy web API, and you need literally change 2 lines of code from your original way you're working with the cloud to use it with Web3 and IPFS and Filecoin. It allows you to create CADs, to point the data to a IPFS network, and to pin the data to Filecoin network. And the first terabyte you use with web3.storage is completely free, but even after this terabyte, it's at least 100 times cheaper than to work with a traditional Google Cloud. If you're working with NFTs, and is there anyone in the audience who's working with NFTs right now, or at least thinking about working with NFTs? Okay. Then maybe it's not as relevant here, but generally there is also a completely free solution for NFTs to work with, and we treat NFTs as a public good, so the knowledge which is created by the artist should be persistent, and it's free for all to use and store the content via NFT.storage. Maybe then we have an audience here which is actually hosting the websites or thinking about hosting a website. Who is doing something like that here? Okay, that's a bit better. So for those of you who are hosting the websites or thinking about hosting them, there is a Fleek hosting tool available to you, which is a wrapper for IPFS and Filecoin, which is designed to a fast, modern, censorship-proof hosting of the websites and web apps. And you can just connect your existing GitHub and publish your website to IPFS and Filecoin. Moreover, we have a Powergate, which is a wrapper around everything. And if you want to have detailed control of IPFS and Filecoin, you can use that. And maybe for backend developers, we also run a project for peer-to-peer distributed databases. The peer-to-peer distributed databases uses IPFS as data storage, and IPFS databases PubSub solution to automatically sync databases between peers. The complexity of running peer-to-peer database is that you always have to maintain the state across all the peers, and we have an additional library which handles PubSub communication all across peer-to-peer networks. It's also all open source and public, so feel free to see the GitHub repository and check how it works straight away for your project. And it's implemented on top of IPFS log, and it's currently actively being developed. It works both in browsers and Node.js, and it's compatible with JS IPFS and Go IPFS libraries. And frankly, one of the most amazing things that I see as a potential of Web3 is that we are also doing the effort to become truly sustainable and green, and not only just by buying carbon offsets, but we are actually doing it verifiably green, investing a lot into the infrastructure, which is accommodating the storage solutions, where we're building an open source tracker where we check the grid which every storage provider uses in order to verify how green is their particular storage. And you can see all the information in the public APIs to analyze and understand how green or efficiently your data is being stored, and you can choose the provider based on the requirements for the sustainability as well. And there are many, many more tools available to you in our OpenStack, so feel free to check the repositories, the libraries. I think it accounts for more than 1,000 right now, but there are 3 major, like IPFS, Filecoin, and libp2p, which you can follow, and then you can discover all kinds of projects in there. And speaking about all kinds of projects, I would also like to go through with you about the possibilities of the Web3. So there are literally a lot of opportunities for you to build. I have surfaced you only the application level tools, but there are also many, many opportunities for you to build user and client interfaces in Web3. You can also build smart contracts and compute layer, which essentially enables what's happening with the front end in the back end. And you can also develop consensus and hardware and networking solutions, which build this composable stack for the Web3 and for Web2 for any internet interaction of the future. There are many, many contexts and opportunities for you to build together. And if you're questioning who is, well, that all sounds fancy, but who is actually using IPFS and Filecoin right now? And all these projects are already using it right now. All the major blockchains and networks are using IPFS and Filecoin either as their storage layer, or they're using more protocols also for peer-to-peer communication. There are also projects like Polkadot, OpenSea, and many other blockchain layers and many other tools which you may use day to day, something like audio service, streaming services, which are also built on IPFS and Filecoin. One of the examples, or some of the examples which I personally enjoy out of those, and I want to surface it to you as well. For example, Internet Archive. It contains the most important humanity data, and it's all backed by IPFS Filecoin. So in case something goes down on their side, it's all archived on our side as well, and we always provide and store it to the public. The Starling Lab. The Starling Lab is a framework for data integrity, but what they actually do, they store the testimonials, video recordings of the Holocaust. And that's something which you never want to lose as a humanity. The history of the important events should be persistent over the web. And it's also backed by IPFS Filecoin to store indefinitely into the future, and making sure that it's not changeable as well, or there is no alterations of it, so that we can always refer to something stable and secure through the IPFS and Filecoin network. There are also applications which you can use day to day, and maybe someone of you is using it already. There is a Huddle, which is a Web3 video meeting platform. There is Audios, which is maybe similar to SoundCloud or Apple Music, and that's an amazing tool where you can also not only see the content which you're listening to, but also see which samples which were used in order to create it, for those of you who are interested in music. There's also LivePeer, which is used for streaming of the videos. And for example, we're also collaborating with an open projects. We are storing right now the whole New York City open data about the city information on the Filecoin. And there are many, many more applications which we are bringing to you over the Web3 and over IPFS and Filecoin. So if you're thinking about joining, or even just interested about our ecosystem, I would say that our ecosystem is the strongest asset in the growing of Filecoin network and Web3. We are right now accounting for more than 4,000 of storage providers worldwide in all continents, in all places, in all different locations, and we are accounting for more than 18 exabytes of total storage capacity, which is right now approximately 1.6 of all total cloud network in the world, which is already amazing and which is already a huge scale, and there is definitely space to store your personal data or to store the data of your personal project. We also have an increasing demand from explosively growing ecosystem. We have In our ecosystem, more than 300 startups building on top of IPFS and Filecoin, and we have more than 9,000 developers contributing to our protocols on a day-to-day basis. The beauty of building open source, and I believe we all are here around building something for the community, you can easily access it all on GitHub. All the code is available to you, and if you think that you can improve something or contribute to it, feel free to do the PRs. We are reviewing them daily, and it's just an open project we're all collaborating on top of. And moreover, IPFS and Filecoin is not then just a storage. We're also right now building the solutions for a compute layer, for programmability, and we're ensuring that our solutions are completely green foundation of the Web3. You can follow us more to see the details on Filecoin virtual machine, retrieval markets building, or just figuring out how to ensure that your project is collaborating in Web3 and building on the basis of contributing to the society instead of having it just locked and not developed by a small community. And to sum it up, in the end, Web3 is, in my opinion, is a complexity of or combination of three core things. First of all, it's decentralized web. It's based on a blockchain where you can have a sequential understanding of what's happening in the history, and it's a large amount of linked data. Whenever you have these all together, working to the best of each other, you have the Web3, and I personally believe that the best way to predict the future is to create it. Thank you for listening.
Fantastic. What an amazing talk. Hey, look, we found a face mic that works. But maybe, yeah, give it up. Actually, the production team, they're doing amazing work. Let's hear it for them as well. Like, you wouldn't have sound if it wasn't for them. Can you imagine? He'd be like screaming, the best way to predict, you know? So, like, production team, thank you. Amazing talk, by the way. How are you feeling? Feeling anxious, nervous, stressed, sweaty?
I'm excited.
Relaxed?
I'm excited for the questions from the
Absolutely,
audience.
yes, exactly. Let's give it up one more time for Konstantin. Really? You hesitated? Awesome. And we have time for 2 questions. Oh, wow. Okay, everybody's interested. You first, sir, there in the back. You may have to scream.
Yeah, so when do we have Git on top of IPFS?
That's a good question. Essentially, what do you mean by Git then? Which functions do you want from it? Well, so the version control is already inbuilt in the IPFS because CID references to exact content, so that whenever you create an alternated version of it, the CID will completely change. So all you need is to have the history of the CIDs, of the content or a file which you're working with, and you have this versioning. So that's, if that's what you're looking for. Complexity of collaborating on a Git is tremendous, and we're also building decentralized solutions like GitHub in order for people to collaborate on it on top of it. It's not built by Protocola specifically, it's built by the community, but these tools are already existing in the web, and I'm more than happy to share them with you once we come to the talk after the main session.
Awesome. Good. And there was another question. There we go.
Yeah, even though you're minimizing points of failures, what do you think is still one of the main points that could be a problem for this whole system?
Can you repeat his question and then answer it?
Yeah. So the question is, what are still the major challenges for the peer-to-peer networks in general? The beauty and the problem of peer-to-peer networks is that they were heavily underdeveloped in the last 20 years when we were super excited about centralized solutions. It's super convenient to work with it. You get all the resources, but at this point you also trade off your personal security, you create silos, bad things. I believe, or we see a major challenge is still the development of protocols in order for them to reach the convenience of traditional Web 2. So we have all this PubSub, maintaining of the databases in a distributed way, but that's all still being under construction, or the community is building right now and focusing on those challenges in order to make them as convenient to use as an existing Web 2 solution, so that the times are still the same, the collaboration is still the same, but it's all distributed in the backend, and you are not relying on a centralized authority to work with that. That, I think, is the main goal of the Web3 right now, and I think we're going step by step towards it until we actually reach it.
Awesome. There's the last question.
How do you avoid hash collisions?
That's a very Good
Can you
point.
repeat the question just for the live stream?
How do we avoid hash collisions? I mean, first of all, 2 to the power of 256 is quite a large number in order to face the collision. But whenever we're actually still exploring the network if there were any hash collisions. To what we've seen right now, there wasn't, to my best knowledge. But I think that's a very good technical research question rather than question to the network itself. But whenever we face it, I think we'll address it as in a way it should be.
Awesome. Let's hear it one more time for Konstantin, everybody.
Thank you a lot.